Welcome everyone. I'm Omer Yuksel, working at Eindhoven University of Technology at Security Group. And I have a background in working with data from the web and text mining. And this is a pet project of mine with the actual aim of familiarizing myself with all the Python packages related to web mining, but also it has this byproduct as the analysis of a website with a relatively strange data set, let's say. So I'll start with some definitions. There are tons of keywords out there. So web mining is defined as applying the traditional data mining techniques to the data collected from the web. And there are three sources of data. It could be the structure of the website. It could be the user logs, such as the clicking behavior and such, or it could be the content of the website, either generated by the provider or generated by the users. So in this work, I'm focusing on the content. And there are, like, why would people do this? The main motivation is, of course, like for commercial purposes, the profit. It could be used for instance, creating targeted ads or for a website owner to keep their users as much in the website as possible to maximize their ad gains. On the other hand, it could also be used just for like more academic purposes, just to gain an insight on a community, see how they behave, what drives them, how are they affected by the cultural situation, and etc. So in here, my motivation is mainly the second, because this is just a pet project and I'm not doing it for profit. So the source of my data is Ekşi Sözlük, which is a Turkish website in a dictionary format. So it's a collaborative dictionary, that's the best way to describe it, and it's inspired by Hitchhiker's Guide to Galaxy. And we have the threads like this, and we have users just posting definitions on these threads. And it has format-wise, it's a bit similar to Urban Dictionary and Reddit, but as far as I know, it's not a rip-off of either, and it has been around more or less the same time since those two websites. Then I'm focusing on a specific thread in there, which is called Ekşi İtiraf, translates to sour confessions. So there are these bunch of websites out there on the internet already that people just pour their heart out, complain about something, confess about something, like talk about their relationship problems and etc., just hiding behind their pseudonymity. And one user in this website was complaining that that's what the website was turning into, and he started this thread as a parody. And after a while, the parody thread actually turned into an actual confessions dump. So why this particular thread and why this particular website? Well, it's partially because it's relatively untouched, so unlike the datasets available on Kaggle or Twitter datasets or Reddit, well, not many people are familiar with Turkish, so so the dataset is fresh and untapped. The other reason is for this particular thread, it's one of the largest and relatively interesting threads, so most of the threads have like just repetitive comments about like either politics and such, but in here we actually have people talking about their personal business. So it's like, it has this high density of emotional content as well. And finally, this is in Turkish, and most of the natural language processing is being done in English, and Turkish can be a quite pain in the neck to work with, so there's an extra challenge of working with a quite different language. So a little bit about the Turkish language. It has its own family called Turkic, and it's pretty much the countries in between Turkey and Russia and China speaking in this language family. And it doesn't really have any relations to the languages of the countries surrounding Turkey. So, for instance, the Iraq, Syria, they speak Semitic. Georgia, Armenia, Greece, Iran, they are Indo-European. So it's quite different from, you can see that it's really different from English and French, and like grammar-wise it has no similarities. But since, due to the geography, it has quite a bunch of loanwords, so mainly from Arabic and Persian, but also starting from 19th century, a little bit from French as well. Some other characteristics, well, extended Latin, just like a bunch of European languages. So, and one peculiarity is, so there is this lower I without the dots, and the uppercase version is I, and so that can be quite a pain in the neck if you're trying to write a trying to use a regular caps function on a Turkish text. And well, I don't have the statistics for it, but there are way too many homonyms, so that can create quite a bit of ambiguity when you are doing text mining. And finally, it has a lot of it makes extensive use of suffixes. So I'm not going to pronounce this, but yeah. So all the prepositions, phrases, and etc. can be just added as a suffix to a word. So that makes it, again, extra pain in the neck to just work with the language. So the steps I'm going to take is, first I'll do the data collection using ScrapEye and Beautiful Soup. Then some pre-processing. And then after that, the main bulk will be on the exploration of the data. Then finally, I will try to do some prediction with using scikit-learn. Some core concepts first. So we have users, which are called authors, and they post entries in this website. So the entry is our main data point in here. So all entries have timestamps, and there are two measures of popularity of an entry, either upvotes, downvotes like in Reddit, or they can be bookmarked. The number of upvotes are not visible to public, so I'm using here bookmarks as the metric of popularity. So to start with mining, I use ScrapEye, and which is relatively straightforward. If the site has a kind of a predictable structure, you can just add in the expat queries, and then you just fill in this parse function, and it just works as a loop. So either the function yields a new object, in which case I call it an entry, or it yields the next page to visit. So the text by itself is in rich HTML, so I also use Beautiful Soup and convert it into plain text. So that's what I get out of the web crawling. It's in JSON, and yeah, it has pretty much all the information that I need for the analysis part. First, yeah, we tokenize the text. So we get a list of words out of the raw text. So that's just regular expressions, and on top of the regex, you just add the special characters as well, and then yeah, you get a sequence of words. Then the next step is removing the stop words. Most of the time they are not really needed. Also, that also turns out to be true for my analysis. So they are the function words such as and, at in the English language. And yeah, I also noticed that the stop words library for Turkish language is not really comprehensive. The next step is stemming. So that's already been explained in the previous talk. So that makes my life much easier. If you have a good stemmer, this whole huge massive thing will actually turn into Czechoslovakia. And that more than halves the dataset that we have started with. So it reduces the dimensionality by half and makes everything easier to work with. And in here I use the snowball stemmer for Python to do the stemming. So next is exploration. So as you see, the dataset is not massive. It's 90,000 entries, like enough to just play around with, but it wouldn't be considered big data. We have around 16,000 authors, and most of them are not prolific posters. So like the median is just 2 posts per author, but there are some people that are just like post thousands of entries into the thread. They are just pretty much addicted to it. And you can also see that the average entry is actually quite short, so the characters per entry. Then the first, I wanted to look into distribution of words. So the x-axis here shows the ranking by frequency, and y-axis is the frequency of that word. And it's in a log-log scale. So Zipflow says for the text data, when you do this log-log scale, you should get a straight line, but that's not really like in real-world text, that doesn't always hold true. But if we remove the first top 1,000 words, it looks a bit closer to zip in here, at least on this part. And I haven't done the like the statistical test for it, but so far it seems to be pretty much similar to the properties of text in other languages as well. And if we look into, if we look closer into words that occur the most, so people, so there's this dictionary that occurs a lot because people just, most people who write in that thread, they tend to use this Dear Diary format. So instead of Dear Diary, they go Dear Dictionary. So this is why that occurs really often among a bunch of more personal sounding keywords. Then the next is, so I want to eventually predict the popularity. So I wanted to look into how these are distributed. And in the log-log distribution, we see again this something similar to a power law. And this could be partially caused by some preferential attachment mechanism in behind. So once an entry is popular, it's more likely to be read by other users, which will read it and again click favorite. So it has this mechanism of reach getting richer. And we see that like 26% of the entries are not favored at all, and 56% has been favored at once, and then yeah, it's the rest is the popular ones are relatively sparse in the dataset. One thing the users in the website complain about is not all entries have the equal visibility, because the way the website works is it lists the first entry of the day on the top. So if you make a comment at midnight, then you have a higher exposure compared to other comments. So that led a lot of users to complain. So I just wanted to see whether this is a genuine complaint or not. And we can see that in midnight there's this spike compared to other times of the day. So, and we also see that people tend to save their best stuff for the midnight, actually, just probably for this reason, just to get as much popularity as possible. So the next step is machine learning. So this is pretty much the work in progress part of the pet project. So I wanted to see whether you can predict the number of, predict the popularity of an entry just based on the text you see. And first we have the vectorization. So we, again, you remember the bag of words from the previous talk. So we have this sequence of words and we convert it into a vector. And the length of the vector is equal to the number of unique words in your vocabulary. So in here we have, just for the sake of the example, it's 4, but in the actual dataset it's in the 150,000 and such. Then, since we cannot really work with this dimensionality, especially with the given data size of 60,000, we want to do a reduction. And one possible way to do it is the topic modeling, so LDA. So it models the document as a distribution of topics, and each topic is actually a categorical distribution of words. And these topics are inferred via Gibbs sampling, which more or less like puts the words that tend to co-occur into the same topic. So the parameter we give for LDA is the number of topics, and these topics are actually like not labeled topics, but abstract entities. But they can sometimes, when analyzed, they can also be labeled. So this is the result of the LDA. And I listed some of the topics that actually make sense in the dataset. And yeah, we see that, yes, there's stuff about pretty much human organs for some reason. The music and social media, people complaining about the rich. And this meta part where people actually talk about the website and the thread itself. And finally, yeah, some more stuff about relationships. But this is not always guaranteed, so you cannot always label a topic. You can also have quite like seemingly nonsensical ones, such as like cat and mirror and water. So my task is to predict the number of favorites, and so this could be modeled as a task of regression. So so number of favorites as the parameter I'm trying to predict, and the text as the entry. But that's not a really good idea, because first, most of the regression methods that are available tend to work with floating point numbers, and they can also give you negative values. So it would really limit the choices of regression methods out there. The second reason that I'm not doing the regression is I don't actually care whether an entry gets, for instance, 200 bookmarks or 500 bookmarks. So I could just, I'm more interested on whether an entry is popular or not. So I decided to make this into a classification task instead, and just created 3 classes, which is an arbitrary choice, but I have to, again, decide, put a threshold somewhere. So the ones that get more than 5 bookmarks, I call them, popular. And between 1 and 4, it's somewhat popular, and the ones that get 0 bookmarks are just, unrecognized. And the data is time dependent, and like the goal of machine learning in here would be to predict the future. So given a model that is learned, we would like to see whether some future entry that we write or we observe can get high popularity. And so for this reason, when I split the data into training and test sets, I don't break the sequence, I don't do any shuffling. So 80% of the data is the first 80%, and the 20% of the test set, that's the future. And not very surprisingly, actually, when we do the cross-validation on training data with the shuffling and everything, it's around 60%, and with the when we use the test data without the temporal overlap, it's around 50. And this can be actually achieved just simply by writing a dumb classifier that classifies everything as somewhat popular. So that means just by looking at text alone, we cannot really predict whether an entry is going to be popular or not. And there's a very simple reason for this. Your entry, your text can be really good and can have a high quality and can be attractive, but this popularity depends on external variables. Like you would need the right time, you would need the right users to be logged in, maybe you would need the stars to be aligned at the right way. So this external dependence ruins the text's ability to predict the popularity alone. And I decided to just for the sake of it, I discarded the text and tried to repeated the classification with just only two features: the time of the day and length of the text. And again, the results I get are not too different from what I get when I use the text entry. So that also confirms that, yeah, just text alone cannot really help me with this task. To sum it up, yeah, I walked you through the steps of starting from the web. Then we create some structured JSON data. And after that, there's exploration. Then there's a little bit of machine learning. And as far as I can see, like the main story in here is that if you want to, like if you are really after internet points, don't bother with the quality of your text that much. Just try on different times and just spam as much as possible instead of working on your quality. I think the quantity will guarantee you better internet points. And there's still a bunch of things I would like to try. First, I want to see whether instead of using words as features or topics, whether using character engrams would help. Second, perhaps instead of trying to predict whether an entry is going to be popular or not, I could focus on the features that do the distinguishing. So which of them are the most important ones among the popular entries. So I could, for instance, do supervised learning and see what's similar between these, unsupervised learning and see what is the similar underlying thing between all these popular entries. The other thing is these entries are not really independent from each other. Even though the place is more of a dictionary and not exactly a forum, and people are discouraged from directly addressing each other, there are actually conversations going on. And tracking these conversations might be a challenging and interesting task. And given a large enough data set, not just this thread, but other threads in the website, we can actually create a chatbot that happens to be highly opinionated. So that's something that I would like to try with when I have more computational resources. And finally, when this matures enough, I would like to try this with other datasets, larger ones, the ones available in Kaggle, perhaps the Reddit dataset, and see where this leads to. So thanks for listening. And I wanted to show this at PyData so that I could get feedback from people that are more experienced in text binding than I am, and see their opinion and give me directions. So feel free to give feedback, questions, and also talk to me after this presentation. Thank you.